Today I'm going to teach you the three different types of bonding: ionic bonding, metallic bonding, and covalent bonding. I'm going to start with ionic bonding. You're going to learn how electrons are transferred during ionic bonding and how to draw dot and cross diagrams to show this. Ionic bonding only happens between metals and non-metals. They react to achieve full outer energy levels or to fill their outer electron shell. On the periodic table, the left side is full of metals and the right side is full of non-metals. I'm going to give an example of ionic bonding using the elements lithium and fluorine. Lithium is a metal and fluorine is a non-metal. Lithium has 2 electrons in its inner shell and 1 electron in its outer shell, and fluorine has 2 electrons in its inner shell and 7 in its outer shell. In this diagram you can see lithium has given 1 of its electrons to fluorine, so now it has its outer shell full, and so does fluorine. When an element loses an electron or gains an electron, it becomes an ion. Since lithium lost an electron, it becomes a plus ion, and fluorine lost one, so it becomes a minus ion. We represent this by putting a square bracket round it and having a plus or minus in the top right corner. Just to recap that, group 1 metals lose 1 electron, forming a plus 1 ion, and group 7 non-metals gain 1 electron and become a minus 1 ion. Both ions now have full outer energy levels, just like group 8 or group 0 noble gases. Now on to covalent bonding. You're going to learn how electrons are shared in covalent bonding and how to draw diagrams to show this. This is hydrogen. It has 1 electron in its outer shell. However, the symbol there is H2. That means 2 of them have to covalently bond and share, so they have 2 electrons in each of their outer shell. The H2 means it's a diatomic molecule, meaning you'll only find them with 2 covalently bonded together. As you can see, the 2 hydrogen atoms are now bonded together, sharing the 2 electrons. The electrons are represented by a dot or a cross. There are 3 ways to show covalent bonding: an energy level diagram on the left, dot and cross diagrams in the middle, or stick diagrams on the right. This is another example, but for the diatomic molecule chlorine instead. Now on to metallic bonding and alloys. You're going to learn the features of metallic bonding and describe the properties of pure metals and alloys. Strong electrostatic attractions between the sea of delocalized negative electrons and the positive metal ions are called metallic bonds. Metallic bonds are very strong. Metals have extremely high melting and boiling points because a great deal of energy is required to break the strong metallic bonds. Metals consist of giant structures of atoms arranged in layers. The electrons in the outer energy level of each atom are delocalized. This means they are not attached to any specific atom and float around. Metals can be bent or shaped because the layers can be pushed over each other. This diagram shows the electron arrangement of 6 lithium atoms. The electrons in the 6 lithium's outermost shell deattaches and becomes delocalized. Scientists call all these delocalized electrons a sea of delocalized electrons. Metals are extremely good conductors of heat and electricity because the delocalized electrons can move it from one end to the other. Thanks for watching, and I hope you found this short video on metallic, ionic and covalent bonding useful.